Hello friends, welcome to my video lecture. I am Professor Vaishali Shinde from KK Arts, Commerce Science and Computer Science College, Kakasaheb Nagar. My topic is Stereoisomerism. This Stereoisomerism topic is included in the syllabus of SYBSc Organic Chemistry. First of all, we see that what is meant by isomerism. Then next we see what is stereoisomerism. We all know that isomerism means they having same chemical formula but different structural formula, and stereoisomerism is the spatial arrangement of atoms in which molecules have same molecular formula and sequence of bonded atoms but differ in the three-dimensional orientation of their atoms in a space. Then next we see the conformation of cyclic compound. The most important cycloalkanes is cyclohexane having molecular formula C6H12. Cyclohexane is non-planar molecule and exists in two conformations that are free from angle strain, and these two conformations are the chair conformation and boat conformation. There are some factors which directly affect the stability of conformations. There are three factors. The first is angle strain, second is torsional strain, and the third is dipole-dipole interaction. First we see angle strain. Any deviation from the normal bond angle, that is 109.5 degree, causes the angle strain in the molecule and hence decreases the stability of molecule due to poor overlap of atomic orbital in the formation of carbon-carbon single bond. In cyclopropane, all the carbon atoms are sp3 hybridized. The carbon-carbon bond angle has to be compressed from 109.5 to 60 degree. This introduces an angle strain. This is the first factor. The second, torsional strain. We know that the staggered conformation is more stable than the eclipsed conformation. Hence, any deviation from the staggered conformation is responsible for torsional strain, due to which the internal energy increase and stability of the conformation decreases. For example, eclipsed and staggered conformations of ethane. Here we see the two figure. In first, that is eclipsed conformation, and second there is a staggered conformation. In eclipsed conformation there is torsional strain is present, while in staggered conformation there is no torsional strain. And the last factor is dipole-dipole interaction. It is the attraction between the positive end of one polar molecule to the negative end of another polar molecule. Example is HF molecule. The special kind of dipole-dipole interaction is hydrogen bonding, in which hydrogen atom serves as bridge between two electronegative atoms holding one by covalent bond and other by purely electrostatic force. Here we see the example HF molecule. In that HF molecule, hydrogen is highly electropositive while fluorine is electronegative. Next point, chair and boat conformations of cyclohexane. In chair form of cyclohexane, there are two types of position, that is axial and equatorial. The axial position point perpendicular to the plane of the ring, whereas the equatorial positions are around the plane of the ring. You should notice that adjacent axial position point in opposite direction. The same is true for the equatorial position. The axial and equatorial positions can be highlighted. Here axial and equatorial bonds in cyclohexane. There are three figures. In first figure, we see only axial hydrogen atoms. In second, only equatorial positions. And third figure, we see axial and equatorial positions. In the chair form of 4 carbon atoms are in one plane, that is C2, C3, C5 and C6. One carbon atom, that is C1, is above the plane and one carbon atom C4 is below the plane, and vice versa. Second, both conformation of cyclohexane. In the both form, again 4 carbon atoms are in one plane, that is C2, C3, C5 and C6, while C1 and C4 are both above the plane or below the plane. The chair and both forms are interconvertible by rotation of carbon-carbon single bond. The next point, the most important point, ring flipping. First we see what is meant by ring flipping. When one form of chair is converted into another form of chair, then it's called as a ring flipping. Means what happened? After ring flipping, the axial bond becomes equatorial and equatorial bond becomes axial. Again we see the two diagram. In first diagram, there is a equatorial bromocyclohexane, and after ring flipping, the equatorial bromine get converted into axial position, that is a axial bromocyclohexane. The most important point is the comparison of chair and boat conformation. Means the question is, chair conformation is more stable than boat conformation. Why? Then we write here answer. Both chair and boat conformations of cyclohexane have no angle strain, as all the bond angles are 109.5 degree. Again we see both chair and boat conformations of cyclohexane have no angle strain because all bond angles are 109.5 degree. In chair conformation, the hydrogen atoms attached to any two adjacent carbon atoms are staggered, and hence the torsional strain is minimum. While in boat conformation, the hydrogen atoms attached to any two adjacent carbon atoms are eclipsed, and hence the torsional strain is maximum. In boat conformation, the C2 hydrogen atoms are eclipsed with C3 hydrogen atoms. Similarly, C6 hydrogens are eclipsed with C5 hydrogens. The two hydrogen atoms are attached to C1 and C4 are called flagpole hydrogens, that is HF. These two hydrogen atoms try to repel with each other because the sum of Wonderwall radii of two hydrogen is 2.5 angstrom. But the distance between two flagpole hydrogen is 1.8 angstrom. Such crowding is known as Wonderwall strain or steric strain. Thus, torsional interactions of the four pairs of eclipsing hydrogens and flagpole interactions increases potential energy of the molecule in boat conformation. Hence, the energy of boat conformation is 7.1 kilocalorie per mole higher than the chair conformation. Hence, finally, the chair conformation is more stable than boat conformation. Here we see two diagrams. In first, it is a chair conformation. In second, boat conformation. In chair conformation, all hydrogen atoms are in staggered, while in boat conformation, the hydrogen atoms are in eclipsed. And we know that if the hydrogen atoms are in eclipse, then it creates torsional strain, or the torsional strain is maximum, while the hydrogen atoms are in staggered position, then the torsional strain is minimum or there is no torsional strain.